In this demonstration, we're going to show you how Solid Edge preserves 3D intent from imported 2D drawings to imported 3D models. We're going to be importing a model that we're going to place in this particular area of the assembly. This is going to be a bracket that's coming from SolidWorks. So select the SolidWorks part, and then we just simply need to specify a template, a Solid Edge template, to bring that into. We have a whole host of formats that we can bring into Solid Edge, and in this case I want to hide some of the surfaces that came in along with the part. You can see now we have a solid model imported from SolidWorks, and we'll just save this as a Solid Edge part. Once we have that saved, we want to open up the associated drawing file. We have a nice AutoCAD translation wizard which walks you through the steps to importing a drawing. You can see that we support the preview where we can show the drawing before we bring it in. We have complete layer control. You can see these are the layers that are associated with this particular file. We also support the black and white option in AutoCAD, where if you have a black background, the lines show up white, and if you have a white background, they show up black. We can map all of the different things to Solid Edge, including the color to align with. And we're just going to open that in Solid Edge. You can see it looks just like it did in the preview. The thing to note here is the scale at which this drawing is brought in. It's at half scale. And we also want to take note of the scale in the detail view, which is 1:1. This is going to be important when we run the Create 3D command, which allows us to transfer these manufacturing dimensions directly onto the 3D model. I'm going to take advantage of the layer control and hide a few layers before we run the Create 3D command. Within the Create 3D command, we can specify the part file that we just brought in and saved into Solid Edge as the file to add these dimensions to. Here's where we set the scale and which view we're going to start with, and we also need to set that we want to include all the dimensions. Select the front view first, and then select the two remaining views. And when we click Finish, those views are transferred to the 3D model in the correct orientation. You can see as we shift between the different views in the 3D model, you can see that all of the sketches line up with the model. At this point then, we will select a particular user-defined set and tell it to attach the PMI dimension, which you can see transfers the 2D manufacturing dimensions from the sketch onto the 3D model. Once those are on the 3D model, they become driving dimensions. You can see we have an important dimension here of 320, and that corresponds to the transaxles. And so we have a nice 3D measuring command within Solid Edge that allows us to determine what that distance is between those transaxles, and we can see that it's 318 millimeters. We switch back to the bracket, and you can see that that manufacturing dimension now becomes a driving dimension on the 3D model. You can see that it's tipping the ears, which is not exactly what we want to happen. So we can change that just by simply selecting some faces within the model. If you get too many faces, you just simply click those selected faces again, which deselects them. And then when we make that modification, remember we want that to be 318 millimeters, you can see that it's moving symmetrically, and that's due to our live rules within Solid Edge that keeps this part symmetric. Another thing we want to change is the width. You can see that again it's changing symmetrically on both sides, and we want that to be 32 millimeters. Just need to make this thing a little bit beefier than what it was coming from SolidWorks. We'll go to the next view, and once again we'll attach the PMI dimensions from the 2D sketch to the model. And again, those become driving dimensions within the model. We want to keep the thickness consistent, so we'll make this also be 32 millimeters. You can see how we can drive the 3D geometry with those manufacturing dimensions. Because we made that change, we need to make our pocket back to 15 millimeters, which is what it was before I changed the width. So Just type in that dimension. Just like in 2D, you can adjust the PMI dimensions on the model so you can read them a little bit more clearly just by simply dragging them around. Notice the configuration of the holes in this model. We need to check the configuration against the assembly. You can see that in the assembly it's more of an L shape, that the holes all align horizontally and vertically. So we'll switch back to the bracket, and we can use the steering wheel to move that hole, or we can just simply use a 0 dimension, which will make those holes line up horizontally. So once we've made those tweaks, then we also want to make some more changes. We want to add the next view, the front view. We want to attach those PMI dimensions to the model. So again, it's as simple as a right click and tell it to attach PMI, and you can see those PMI dimensions jump onto the 3D model. Again, to keep this thing consistent, we're going to change it to 32. Again, note because of live rules, it's keeping the symmetry. So remember that we also had a detail view detailing the size of the hole and the location of the hole within the ear. So if we go back to our drawing, we'll turn that layer back on, detail layer, and we can run the Create 3D command again, and this time we just simply need to change the scale, which is going to be 1, and we also want to change the view. We want this to be placed on the top view. This is just going to save us some manipulation once we get it in the 3D model. See, it adds it to the 3D model, and we can move our steering wheel. We can reposition our steering wheel and take advantage of the synchronous technology to move this sketch within the plane and line up with a key point. This is true top-down type design. We want to attach those dimensions also to the 3D model and then make some changes. We want to change the hole size from 10 millimeters to let's say 11 millimeters. You see how it drives that 3D geometry from that manufacturing dimension. Next thing I want to show is that we can create a drawing again from this 3D model using those manufacturing dimensions. So we're just going to run our drawing view wizard. This is going to allow us to specify the views that we want placed on the draft view, in this case the top view, the front, and the side view. It automatically scales the drawing or the model to fit the background sheet. And we may want to change some things like show tangent edges within the view. The most important thing is then to retrieve those PMI dimensions, those manufacturing dimensions, back to the drawing. You can see that it adds all of those back onto the model. Very, very powerful. And then we'll save this as a new draft sheet. Go ahead and close the draft sheet. We'll also close the model file and close the original drawing. Now that we're back in the assembly, what we want to do is place that bracket in the assembly. So from our parts library where we save the part, we'll just drag it in. And while we're in the place part mode, we can position the bracket a little better so that it will align correctly with the holes. So here we're going to select the cylinder in the bracket and align it to the cylinder in the sheet metal part. Do the same thing again. Get another alignment. Now that we have that in position, the only thing left to do then is to center this within the sheet metal part. And we're going to do that using synchronous technology. We can select the entire model and position the steering wheel to the midpoint and align it to a key point within the assembly. Now that we have it centered, you can see that it doesn't exactly fit our particular application, so we need to make some modifications. And right from the assembly, we can select faces down inside of a part using synchronous technology, and then use the steering wheel to position that geometry, those two faces, and move them to a key point within the assembly. Now notice live rolls is still taking effect, and it's modifying both sides so that it remains centered in our sheet metal part and mates to both sides of the sheet metal. We're going to in-place activate into our part. We're going to make a few other modifications. You can see that I need to move these ears back so the holes line up. But first I want to make a modification. I want to stretch the middle section of this bracket. And with synchronous technology, even in 3D, we can do a stretch type operation where we can move a particular area of the model back to a specific value, in this case 12 millimeters. In the context of the assembly, true top-down design, I can select the hole and then using synchronous technology move that particular hole along a vector in a line to the center of the transaxle. Notice that both sides are moving, again due to symmetry in the part. So there you can see everything lines up. At this point, we will close and return back to the top level assembly. And I want to turn all the parts back on in this particular assembly, so I'm going to go to a configuration of all. And when I do that, notice that the bracket disappears. Well, that bracket I built at the top level, but I may want that buried down in the subassembly with the rest of the framework, and so I can just simply transfer that into that subassembly. But now when I go to my configuration manager, I don't know where that part exactly is. It's a new part, it has not been added to any configuration, so we have a nice tool to go in there and search for any new components that have been added to the assembly that have not been specified in any particular configuration. And so at this point, with this nice table type format, we can simply select where we want that part to be visible, in which configurations, just by placing a check in that configuration column. Once we're done with that, we can save the configuration, which writes it back to the file and becomes a permanent record of that part in that particular configuration. And when we apply the configuration again, you can see that that part is turned on. So we've made some modifications to this part while we were in the context of the assembly, and so now let's go back and look at the drawing associated with that part. When I open up that draft sheet, it immediately tells us that something has changed. And all we have to do is with one mouse button click, update all the views. When we do that, we get this dimension tracker, which shows the dimensions that have changed due to our modifications that we made in the assembly. If we can't find that particular dimension, you can select on it and tell it to zoom to that part to find it. It even tells us what the previous value was for that dimension before we made the change. We could take this information and put it into a revision block, or we can just simply clear the select set once we've made note of what has changed. So with Create 3D functionality, Solid Edge is able to preserve 3D intent from imported 2D drawings to imported 3D model and turn the manufacturing dimensions to the drivers of the 3D model instead of simple model dimensions.